Imagine a battlefield where a single machine is capable of turning an area the size of a small town into a scorched desert in a matter of seconds. 12 projectiles ascend into the sky one after another, and within a minute, nearly 68 hectares of land cease to exist in their former state. This is not science fiction or an exaggeration. These are the real characteristics of the Russian Tornado-S multiple rocket launcher system, a machine from which it is impossible to take cover at a distance of 200 kilometers. To understand how Russia created a weapon of such power, one must go back several decades to an era when Soviet designers laid the foundation for the most destructive multiple launch rocket systems on the planet. It all began with the Smerch, a legendary system that entered service with the Soviet Army in 1987. For its time, this system was a true breakthrough. 300mm caliber, a firing range of up to 70 kilometers, and 12 launch tubes. The Smerch struck terror into any opponent and had no equal in the world in its combination of characteristics. It was developed at the Tula State Research and Production Association SPLAV, the same design bureau that earlier gave the Army the famous Grad and the no less formidable Uragan. By that time, the Soviet school of multiple rocket launchers was already considered the strongest in the world, and the Smerch became its pinnacle. However, as time passed, by the beginning of the 2000s, it became obvious that even such a powerful system required deep modernization. The world had changed radically. High-precision weapons had appeared. Satellite navigation was no longer the exclusive privilege of strategic missiles, and the speed of decision-making and strike accuracy began to dominate the battlefield. Despite all its destructive power, the Smerch hit wide areas, and its unguided rockets flew along a ballistic trajectory without the possibility of correction. For the end of the 20th century, this was acceptable. But new realities demanded a fundamentally different approach. The designers at Tula Splav understood this better than anyone. It was they who had created the Smerch, and it was they who took on its deep modernization, which was essentially supposed to birth an entirely new weapons system. The tasks were ambitious: to increase the firing range by at least double, to achieve fundamentally new accuracy through guided projectiles, and to automate all processes from aiming to launch. Most importantly, it had to be done so that each of the 12 projectiles could fly to its own specific target, not just covering a square on a map, but hitting specific objects with an accuracy that Smerch operators could only dream of. Work on creating the new system, designated 9K515 and named Tornado-S, stretched over many years. This was not just a replacement of some components with others. Designers had to rethink the very concept of a multiple rocket launcher system. If previously such a system was perceived as a tool for area suppression, it now had to become a high-precision weapon capable of hitting specific targets at a vast distance. Effectively, the line between classical rocket artillery and tactical missile complexes began to blur, and the Tornado-S was at the forefront of this process. The key solution was the integration of GLONASS satellite navigation into the projectile control circuit. By that time, Russia had already deployed a full constellation of 24 satellites in orbit, and the Splav designers gained the ability to use this system to correct the flight of rocket projectiles. The idea was elegant in its simplicity. Add a relatively inexpensive GLONASS receiver and an associated autopilot to the existing rocket design so that the projectile could correct its trajectory throughout its entire flight. This provided a colossal increase in accuracy at a comparatively low cost. In 2017, the Tornado-S officially entered service with the Russian Army. By this point, the system had passed a full cycle of tests and confirmed all stated characteristics. The firing range grew to 120 kilometers compared to 70 for the early Smerch. Accuracy increased many times over thanks to satellite correction, and the automated control system allowed for the preparation time for a salvo to be reduced to a minimum. The Russian army received a weapon that had no direct analogs in any army in the world in terms of its capabilities. Production of the Tornado S was launched in Perm at the Motovilika plants. This is the oldest defense enterprise in the Urals, with a history dating back to the 18th century. It was here, on the banks of the Kama River, that the assembly of the combat and transport loading vehicles of the new complex began, and it was from here that they were sent to the troops. The choice of site was far from accidental. Motovilika plants had specialized in artillery systems for decades and possessed all the necessary production base for the manufacture of equipment of this class. But to understand how serious a step forward the Tornado S has taken compared to its predecessor, it is worth looking at how each of the machines in this complex is designed and what exactly has changed. The heart of the system is the 9A54 combat vehicle. This is not just a launch platform on wheels. It is a full-fledged autonomous combat complex capable of independently determining its location, plotting a route, and aiming the launch tubes at a target without a single crew member exiting the cabin. The base for it is an 8-wheeled all-wheel drive tractor with wheels 1.5 meters in diameter, capable of overcoming off-road terrain, fords, and steep inclines. With a mass of 43.7 tons, this machine accelerates on the highway to 85 kilometers per hour, which is an excellent indicator for equipment of such dimensions. Under the hood is a 12-cylinder diesel engine with 525 horsepower and a cruising range of 850 kilometers. This means that the combat vehicle can make long marches under its own power without being tied to railway platforms or heavy trailers, quickly change positions, and evade retaliatory strikes. On the battlefield, mobility often means survival, and the designers understood this perfectly. But the main difference between the 9A54 and the Smerch combat vehicle lies not in the chassis, but in the electronic interior. Onboard equipment allows the machine to autonomously perform topographic positioning and navigation, displaying its current position on an electronic map. The crew no longer needs to deploy geodetic equipment and manually determine the coordinates of the firing position. The onboard computer does all this in seconds. Automatic aiming of the launch tube package occurs based on data received from the command vehicle, although if necessary, the crew can switch to manual control. The operator fires using a special remote control directly from the cabin, and not a single member of the crew is exposed to danger during the salvo. The second vehicle of the complex is the 9T255 transport loading vehicle, and this is where a real revolution occurred in the speed of preparation for a repeated salvo. With the old Smerch, the reloading process was a long and laborious task. The 9T234-2 transport loading vehicle used an onboard crane to load 9 M55 rockets into the launch tubes of the combat vehicle one by one. Even for the most experienced and coordinated crew, this procedure took at least 15 minutes. A quarter of an hour in an open position, when the enemy can already detect the launch point and deliver a counterstrike, is critically long. The designers of the Tornado S solved this problem radically. The rockets of the new complex are placed in special transport launch containers, and the crane of the transport loading vehicle installs them as a whole unit rather than individually. The result is impressive. A full reload of the 12 tubes takes no more than 3 minutes. A 5-fold reduction in time, from 15 minutes to 3, which in real combat can mean the difference between life and death for the crew. The combat vehicle manages to fire, receive a new ammunition load, and leave the position even before the enemy has time to react. The third element of the complex is the 9S-936 command vehicle. This is the brain of the entire system, from where the fire of an entire battalion is controlled. The onboard computer of the command vehicle receives target data, automatically calculates firing parameters, and distributes tasks among the combat vehicles. The automated guidance and fire control system allows for the simultaneous coordination of several launch platforms, making a Tornado S battalion salvo truly devastating. The entire crew of each vehicle consists of only 3 people. 3 soldiers control a system capable of destroying everything living in an area of nearly 70 hectares. At the same time, automation has reached such a level that minimal time passes from receiving target designation to the first shot. The complex deploys from a travel position to a combat position, aims at the target, produces a salvo, and retracts back with such speed that it is extremely difficult for an enemy to track and hit the firing position. If the combat vehicle is the body of the complex and the command vehicle is its brain, then the Tornado S projectiles are, without exaggeration, its fists, and fists that are incredibly precise and destructive. It is in the ammunition that the main technological breakthrough is concentrated, separating the Tornado S from its predecessor, the Smerch. This difference is as decisive as that between a guided missile and a regular artillery shell. The core of the arsenal consists of 2 types of guided rockets, 9M54 and 9M549. Both have a caliber of 300 millimeters, a length of 7.6 meters, and a mass of about 830 kilograms. In terms of dimensions and weight, they are practically no different from the previous generation of ammunition created for the Smerch. This was a deliberate decision by the designers to maintain compatibility with existing launch tubes and transport containers. However, inside these rockets is a completely different interior that makes the Tornado S a new generation weapon. The design of both projectiles is built on a cylindrical body with an ogival nose cone, that is, a cone with a characteristic elongated shape, and a tapering tail section. 4 folding aerodynamic rudders are located on the nose cone. They unfold after the projectile leaves the launch tube and provide flight control along the entire trajectory. It is these rudders, receiving commands from the autopilot, that correct the course of the rocket with a precision unattainable by the unguided projectiles of the Smerch. The tail stabilizer also deserves special attention for its truly original design. Its surfaces are fixed on a ring base that rotates freely around the rocket body. Thanks to this solution, the stabilizer spins in the oncoming airflow, ensuring flight stability. But at the same time, the projectile body itself remains stationary and does not rotate around its axis. This might seem like a purely engineering detail, but it was precisely what made the full use of satellite navigation on board the rocket possible. A rotating projectile creates immense difficulties for the operation of navigation receivers and the autopilot, while a stationary body allows the electronics to work stably and without interference throughout the entire flight. Under the nose cone of each projectile is a unified control unit. This is the most complex and expensive element of the rocket. It includes an inertial navigation system, a GLONASS satellite navigation receiver, an autopilot, and electric rudder actuators. The strap-down inertial system tracks the position of the projectile in space from the moment of launch, and the GLONASS receiver constantly corrects its data using signals from satellites. 2 navigation loops work in tandem, mutually complementing each other, and this provides that very high accuracy of impact that distinguishes the Tornado S from all preceding multiple launch rocket systems. But the projectile must not only reach the target precisely, it must guaranteedly destroy it. And here, the 2 types of ammunition of the complex complement each other. The 9M54 projectile carries a cluster warhead containing 552 high-explosive anti-tank submunitions weighing 240 grams each. Each such element is capable of penetrating 140 millimeters of homogeneous armor and simultaneously scatters fragments in a radius of several meters. A single projectile, unfolding its cluster nose section over enemy positions, rains down more than 500 lethal submunitions, and taking cover from this rain is practically impossible. The second projectile, 9M549, carries a cluster warhead of a different type. 72 larger fragmentation submunitions. Each of these has a significantly greater mass and damage zone. This makes this ammunition especially effective against armored vehicles, artillery batteries, and stationary objects. Thus, the battalion commander can choose the type of projectile depending on the nature of the target. Small, high-explosive anti-tank elements against infantry and light vehicles, or large fragmentation elements against heavy armor and fortifications. For both projectiles, designers developed a new high-efficiency solid-fuel rocket engine. It was this engine that allowed the maximum firing range to reach 120 kilometers, whereas early modifications of Smerch rockets flew only 70 kilometers and later ones 90. An increase of 50 kilometers or more while maintaining the same projectile dimensions and mass is a serious engineering achievement made possible by a new fuel composition and an optimized engine design. The minimum firing range is 15 kilometers, allowing the complex to be used at relatively short distances if necessary. Another fundamentally important feature is the ability to provide each projectile with an individual flight mission. This means that 12 rockets from a single salvo can fly not into a single square, but to 12 different targets separated by a significant distance from each other. The control unit of each projectile receives its own target coordinates before launch. After exiting the launch tube, the rocket follows an individual trajectory. In essence, one Tornado S salvo is equivalent to 12 separate high-precision strikes delivered almost simultaneously. Any high-precision weapon is only as effective as the target coordinates programmed into it. One can create an ideal rocket with a flawless guidance system, but if it flies to the wrong place, the entire technological breakthrough becomes meaningless. The designers of the Tornado S understood this from the start, and therefore the issue of target reconnaissance and the precise determination of coordinates became one of the key points when creating the complex. The foundation of the Tornado S accuracy is the Russian GLONASS Global Navigation Satellite System. 24 satellites of this system are deployed in circular orbits at an altitude of 19,400 kilometers above the Earth's surface. Working in conjunction with a pair of Luch series relay satellites, the constellation provides coordinate determination with an accuracy of up to 1 meter. This is a proprietary navigation system, completely independent of foreign states, and its existence allowed Russian designers to turn a multiple launch rocket system from an area suppression weapon into a high-precision instrument. According to some sources, the circular error probable when firing a salvo is 0.3% of the firing range. If translated into concrete figures, when firing at the maximum range of 120 kilometers, the deviation of the projectile from the aiming point does not exceed a few hundred meters, and according to some data, designers have achieved accuracy within several meters. Exact figures are classified for obvious reasons. However, the fact itself that we are talking about meter-level accuracy for a 300mm caliber rocket projectile speaks of a colossal technological leap. However, satellite navigation solves only half the problem. It ensures precise guidance of the rocket to the given coordinates. But before guiding the projectile, these coordinates must be obtained. The target must be detected, identified, and precisely tied to the coordinate system. In the conditions of modern combat, where the enemy actively camouflages and constantly changes positions, this is a task of exceptional difficulty. It must be solved by space or aerial reconnaissance using optical, infrared, and radio-technical means of observation. And here, Russian designers applied a solution that can be called truly elegant. Especially for the Tornado S complex, an experimental projectile, 9 meters 534, was developed. And this ammunition carries not explosives, but a small reconnaissance unmanned aerial vehicle, the T-90, which is part of the Tipchak complex. The idea is that the multiple rocket launcher system provides its own reconnaissance data by firing a scout into the suspected area of target locations. The operating principle of this projectile deserves a detailed description. After launch, the rocket flies to a pre-scouted area where enemy targets are likely located. Over this area, the cluster nose section opens and the T-90 drone exits. The apparatus begins to descend on a parachute and simultaneously turns on its onboard observation tools, scanning the situation below. For 20 minutes, the drone transmits video information in real time to the multiple rocket launcher command post, as well as to the command posts of other artillery or tactical missile complexes operating in the area. 20 minutes of aerial reconnaissance is a huge volume of information. During this time, operators at the command post can detect and identify targets, determine their exact coordinates, and make a decision to destroy them. The coordinates are immediately transmitted to the combat vehicles, which by this point are already at firing positions and ready for a salvo. The vehicles have positioned themselves topographically using GLONASS signals and determined the azimuth and elevation angle required for the launch tubes. Next, the combat control and communication equipment comes into play, which on the Tornado S replaced the standard radio station of the old Smerch. This equipment works in conjunction with the automated guidance and fire control system on a single digital platform, achieving full integration of communication functions and the operation of the ballistic calculator. The command vehicle transmits target data. The onboard computer of the combat vehicle calculates firing parameters, and the tubes rotate into the required position. At the moment of launch, the rocket leaves the transport launch container. From this second, the autonomous operation of the projectile's onboard control system begins. The stabilization system continuously receives data from inertial sensors and corrects the rocket's movement with gas dynamic rudders, compensating for engine thrust asymmetry, side wind gusts, and other disturbing factors. Simultaneously, the GLONASS receiver captures satellite signals and begins to determine the current coordinates of the rocket in space. Two navigation loops, inertial and satellite, work in parallel, constantly checking data against each other. The inertial system gives instant information about the projectile's position but accumulates error over time. GLONASS gives absolutely precise coordinates but with a slight delay. Together, they form a closed correction cycle where satellite data continuously refines the readings of inertial sensors, and those, in turn, fill the gaps between satellite signal updates. The projectile flies to the target, constantly refining its trajectory, and at the final point, the deviation from the given coordinates turns out to be minimal. One of the most forward-thinking decisions by the SPLAV designers was maintaining full compatibility of the Tornado S with older rocket types developed for the original Smerch. At first glance, this might seem like a minor detail, but in the real conditions of intensive combat operations, this feature acquires colossal significance. High-precision guided projectiles with satellite navigation blocks are technically complex and expensive to produce. In war, ammunition is consumed at a vast rate, and when the supply of guided rockets runs out, the Tornado S crew is not left weaponless. They can load unguided rockets from the Smerch into the tubes and continue performing combat missions. This gives commanders on the battlefield incredible tactical flexibility. When tasked with destroying a specific target, a command post, an anti-aircraft system, or a communication hub, the battalion uses high-precision 9M54 or 9M549 projectiles, each of which flies exactly to a set point. If the task is to cover an area target, a cluster of vehicles on the move, a field camp, or a troop concentration area, older unguided rockets can be used, which are significantly more numerous in warehouses and substantially cheaper. In essence, the same complex combines the capabilities of a high-precision weapon and classical rocket artillery. Switching between these modes happens with a simple replacement of the ammunition load. In 2021, information emerged about the development of fundamentally new 300mm rockets for the Tornado S. The characteristics of these munitions forced military experts worldwide to reconsider their ideas about the capabilities of multiple rocket launcher systems. The flight range of the new rockets reached 200 kilometers, nearly 3 times more than the early Smerch and significantly more than the 120 kilometers of the base Tornado S projectiles. At the same time, the designers retained all control and navigation systems, meaning the highest accuracy of hitting targets at this incredible distance. 200 kilometers is a distance at which an enemy might feel they are in the deep rear, far from the line of contact. Headquarters, logistics centers, airfields, ammunition depots. All these fall within the reach of a multiple rocket launcher system that was until recently considered a purely tactical short-range weapon. The Tornado S with new projectiles has effectively crossed the boundary between tactical and operational tactical levels, becoming a tool capable of influencing events far beyond the front line. As early as 2022, reports were received that the Tornado S complex was equipped with these high-precision extended-range projectiles, a system that was already one of the most powerful multiple rocket launchers on the planet received another serious argument. Moreover, the new ammunition did not require any changes to the design of the combat vehicle itself. They are fully compatible with existing launch tubes and transport launch containers, which significantly simplifies their introduction to the troops. The modern battlefield is unthinkable without unmanned aviation, and the Tornado S has seamlessly integrated into this reality. In addition to the already described reconnaissance projectile with a drone, the complex is increasingly working in tandem with various scout drones that provide target designation in real time. The drone detects a target, determines its coordinates using its own navigation systems, and transmits the data to the battalion command post. From there, the information immediately goes to the combat vehicles, and within minutes, a high-precision strike is delivered on the target. The cycle from detection to destruction is compressed so much that the enemy simply does not have time to leave the position. According to available data, there are about 20 units of Tornado S in service with the Russian army, and production at the Motovilica plants in Perm continues. Each new machine leaving the factory floors strengthens the firepower of rocket artillery brigades and gives the command another tool for solving the most complex combat tasks. Given the constant improvement of ammunition, from base-guided rockets to the latest projectiles with a range of 200 kilometers, the potential of this system is far from exhausted and will only grow. If you were interested in learning about what the Tornado S is capable of and why this system is rightly called one of the most formidable types of weaponry on the planet, like this video. This way you will help promote our content and let us know that such topics are interesting to you. Be sure to subscribe to the channel so you don't miss new releases, and write in the comments which weapon you would like to hear about next.